Hello? Can you hear me? Oh, really? I can't hear myself. OK, awesome. Um, so thank you for joining me. Today, I'm talking about speculation rules. And I will start with a show of hands. Who of you have heard about speculation rules before? Cool. Some people. Who of you have used speculation rules before? OK, none. I will ask it all the way around. Who of you hates the slow navigation? Oh, yeah, it seems some people love it, but all right. OK, let's go with that. I will start with a quick fun fact. If you have two smartphones, one like 10 years ago and one the latest iPhone, and you install Chrome on both of them, 112 plus version, all right? And you open Google search, start searching for something, and you get some links, and you click on some of these links. Which one do you expect to perform better? Obviously, right? No, it's not. Actually, this one, which is $300, beats this one, which is $1,300. For some reason, this is a winner for two important things. First one is something called speculation rules. That's our topic for today. And second one is because all browsers, believe it or not, all browsers on iOS are WebKit, are merely like Safari in a different skin. You know that? Cool. So to change that, allow me to introduce myself very quick. My name is Medhat Dawoud. I'm a senior engineer working for Miro. Who's using Miro? Everyone. Cool. And I'm also a Google Developer expert in web performance. If you like what you see today, feel free to follow me and find me on Medhat Dev. Cool. Let's dive in. Another fun fact. I claim to have humans are slow and impatient species. That's true. I will prove it for you. First of all, performance is about perception. So if you perceive something as performant, it's performant. And I perceive it in a different way. And over time, over years, this has changed. Look with me in this chart. In 1999, actually, people were perceiving websites that load in 8 seconds as fast. And 7 years later, it gets down to the half, 4 seconds, with the aspiration to have a fast loading website. Today is 2 seconds. Who knows? In a few years, might be in milliseconds. You never know. So we're getting impatient. We need everything to be fast. And at the same time, as we are impatient, we are super slow. If you're driving, you will see that a lot. There is something called stopping distance. And it's a combination between two things. It's reaction distance and braking distance. Reaction distance is the time it takes you as a driver to find the hazard and move your leg and apply the brakes, right? This is known as, in average, 1 second. This is stressful. This is hazard. You're going to die, most probably. So you are moving in 1 second in a hazard situation. So imagine in time to click, it takes between 1 to 2 seconds. You move the cursor, and you wait for like 1 to 2 seconds, thinking, should I click here or not? And this is a lot. This is the thinking time that we're going to utilize to enhance performance for the navigation. And you are not stressful. Imagine yourself in this situation. If you are this soldier, you might be thinking like 10 seconds or something, because it costs you more if you click the wrong link, right? So we are slow. We are impatient. So let's get back to the basics a little bit. How we are loading pages for the first load. If you have a browser and you order something, so we're going to download like index.html, you request it, and then you wait a little bit, you get the HTML, parse it, you find some assets, request it, and there's a waiting time until we prepare these assets, fetch it, and then pre-rendering, and finally, bam, you have the page, right? That's the simplest way that you're loading a page. But imagine if you decided, for example, to load something else. This, in total, is taking around 3 seconds in the best case scenario for some pages, all right? And if you decide to click one of these links, like P1, page 1, imagine what would happen. Exactly the same. So P1, request HTML, start parsing, finding assets, request assets, wait for it, and rendering, and finally, the page is loading, right? And this is happening always in any navigation event. And you cannot avoid it. Maybe this time it takes a little bit less, because some of the assets could be cached or something. And if you click on P2, P3, P4, always be the same. That's exactly what we need to fix. So without speculation rules, if you have a navigation event, clicking on something, it starts over the whole process. If you click again, you get, maybe it's a different timing as well. It's not the same always. Every page is different. And again, another event, every page starts over. But with the speculation rules, you can imagine that index HTML doesn't change, because speculation rules is not fixing the problem with the first load. That's a different story. That's something that we can fix in a different talk about performance of the first load. But now we are talking about the events. These events for each page can change the time it loads like this, only with applying speculation rules. We will learn how to do that. And even with some configurations, it can be down to that instantly. Just click on it, and you have it. That's what we are going to learn today. So what we are aiming for is to have navigation between pages. It's like holding a book, and you are flicking the page. Imagine that. If you have a page that is being loaded dynamically, it takes the time to download the ink and showing everything, that would be cool, right? Can you recognize this? From what? Yeah, Harry Potter, right? That would be cool. However, it wouldn't be cool in this case, that you suddenly get ink not found, right? So you tear it down and throw it away. So we need every page in the web to be treated like a page in a book. You need to just flick it, and you find a new one. That's what speculation rules is doing. So we need instant navigation to remove this barrier of the network and rendering time that we are showing the loading indicator during that. So instant navigation can be done in different ways. First thing is called back-forward cache. This is coming out of the box for all the browsers, more or less, right now. So the only thing that stops back-forward cache is if you are hindering this event of unload. But otherwise, you have it, and it is in the DevTools. You can check it yourself. Another thing, this Omnibox on top of the Chrome, if you write something and you find some suggestions to it, and you click, you feel that it's in instant. It's actually loading everything ahead of time. That's another way Google is doing it. And we used to have this link tags with relationship, pre-render, and prefetch. Who's using that? Cool. This is deprecated, all right? So don't use it from now on. This is going to be replaced with speculation rules. Speculation rules now is being supported in some browsers. We will see that. But the bad news here is that these two are only supported in the multi-page applications. Single-page applications are not yet supported in that. But they're working on that, OK? Our focus will be only for speculation rules for this talk. So speculation rules API is simply doing a pre-render for the pages ahead of time in advance. So the user, when they click, they feel that they are flicking a page, simply. You remember this? We're loading a page. The first page we don't care about. But when you click, when you parse this page and you find that there is speculation rules, we will learn how to write this script later on. You find that there is two pages, P1 and P2, and you would like to render them ahead of time. What the browser is doing is actually doing everything like rendering them, but in a different way. Imagine them in a hidden tabs. So they are doing all the same thing, but in a hidden tabs, so you don't see them. We speculated. We guessed that the user is going to click on that based on some configurations we learned. So imagine that now you are clicking on the same page again, P1. What would happen? It will load immediately, instantly. It will just get it from the cache and throw it in front of the user, so the user can understand that, OK, it was there all the time. This is cached for only 5 minutes to give a head start for the user. So when they click, they find it. But after 5 minutes, it is discarded and start over again. OK? That's simply what speculation rules can do. And how to write it? It's simply something similar to a JSON-like way. You write 3 things. First of all, action. So you decide whether it's a prefetch or pre-render. That's up to you. We'll learn the difference now. And you bought a selector or a target, and this target can be different things. It can be URL. You can say, all right, any URL that starts with this number or this code or whatever or ends with that, please put it in a target for speculation. It can be a regular expression. You can have a wildcard, catch everything. Don't recommend that, but you can do that. And it can be a CSS selector, like the one that you can see right now. The funny thing here and important thing is the eagerness. This changes all the way every action, how it works, how you are triggering speculation rules at all. We have immediate, moderate, and conservative. We'll talk about them in a bit. And keep in mind that this is only supported in the Chromium-based browsers for now. It will be in the future supported elsewhere, but this means that you can support or serve it as a progressive enhancement for the user, but you cannot just serve it for everyone yet. And this, by the way, explains why it works on the old phone, the flagship phone, and doesn't work for an iPhone. Because iPhone is only using WebKit. It's Safari, right? So let's talk about eagerness. We have 3 of them. The first one is called conservative. And if you set the eagerness to be conservative, this means this speculation starts in the time you are mouse down or pointer down. This means that you are for sure clicking on this. So you get a head start of between 100, 200 milliseconds. So we load this ahead of time. And there is some regulations that prefetch and pre-render only fetches or pre-render 2 links maximum. So what if you are targeting like 10? Every time you're targeting the third one, you are discarding the first one, and so on. First in and first out. If you used to have eagerness moderate, this is a little bit better, because if you hover over any link for like 200 milliseconds, this means that most probably you're going to click. Doesn't guarantee, but yeah, it might be. This gives you a better head start, like 400 milliseconds. First in, first out as well, 2 links. And the final and bigger one is immediate. This means that if you find any link that is coming in this target that we stated, load it ahead of time. Don't wait for the user to hover over it or click on it or anything. This is dangerous to do, because you cannot guarantee that all the targeted links are going to be linked for sure. But you are giving a head start. It's a maximum. It can be like an instant, like the one I showed in the beginning. So it's very hard to manage that a little bit. What is the optimal eagerness? You have this chart is between the accuracy, what you are speculating is accurate, and the head start. What is the amount of time that you're saving when you are speculating these links? If it's a conservative, this means that you are speculating as the user is clicking, is mousing down, right? This is the highest accuracy, you're sure, but this is the lowest head start. Gives you like 100, 200. If it's moderate, gives you in between. Yes, it's highest probability since he hover over this link, but in the same time, gives you a better head start. And of course, immediate gives you the maximum head start, but the lowest accuracy. You might speculate like 100, not 150 links, but none of them has been clicked. So it's a wasted bandwidth. So the best is to do it something in between. It's to predict what the user is doing and learn from some analytics and change the speculation rules dynamically. And this we will learn in a bit. This is recommended to do. So instead of rendering, pre-rendering is rendering the full page, which is costly and big page. But you can prefetch. Just fetch the first one and do the parsing ahead of time. This saves some time. So you can prefetch with moderate, only by hovering over. And when clicking, you can pre-render. So you get the best of 2 of them. And instead of having like 100 milliseconds or 400 milliseconds, you can get like 600 milliseconds or something ahead of time. And believe me, 100 milliseconds is huge in the world of performance. It's not, we're not thinking in seconds. We are humans. We are slow. We are thinking in seconds. But the web thinking in milliseconds. So 600 milliseconds is a lot. So how we are measuring performance, just to think about how the user see it. First of all, the user thinks, OK, is it happening? The first thing is painting. We measure it with something called first contentful paint, right? And if the user sees the biggest part in the screen is loaded, this means that it's the largest contentful paint. This is a meaningful thing is happening, and it's useful. He can interact with it, right? Just to have an idea how we can measure that. And lucky enough, Google did the math for us and find out with researchers what is good, what's bad. So any largest contentful paint below 2 seconds and a half means it's good. Anything above 400 is poor, and you need to work on it. So you can use this as like a baseline, but it doesn't mean that this is the best thing that you can do. Moving on, just before going to a demo, I would like to let you know that there is already speculation rules is shipped in all the Chromium-based dev tools, and you can find it in application. You'll find something called speculation rules or loads. Inside it, there is rules and speculations. We'll see that. And there is something number 3. You will see it. It's actually anything speculated changes the whole dev tool. I will show you in a bit. So let's move on for a quick demo. Here's a quick demo created actually by the Chromium team, Chrome team. All the links on top for these fruits are being speculated, or most of them. So if we go here, open application, open speculation loots, and then open maybe speculations, you'll find that all of them are now standby. They are waiting for you to do something, maybe hover over it, all right? So if we start, for example, with pitch, have you seen that? Status changed from being not triggered to ready, right? If I triggered, for example, let's say cherry or grape, you'll find another one, it's ready, right? If I decide to move on to coconut, you'll find that the first one is failed now, it's not triggered because 2 only is being held. And till now, we didn't see the effect, right? If we go for apple, it's ready. When you click on it, this is huge. This is a huge navigation. You would like to see how huge it is? I will reload, because now we are speculating on navigation event, but not the first load. If I reload the page, let me just reload the page, this is 200 milliseconds in general. But with speculation, we did all the math ahead of time, and then now we can have this, this benefit. If we go back and speculate for apple, it will be like that. But if I didn't wait for like 200 milliseconds, just go ahead, 100 milliseconds. This is not a lot. But for some of the projects that you're working on, this LCP can be big. And with having this head start, it might have a bigger impact as well. OK, so I would like to show you something else as well, that you can, using that, you can do that dynamically with JavaScript. And with JavaScript, you can just copy this. And let's see if there is one of these links are not speculated. You can see here that all the links here are being speculated, are the fruits. So these recipes are not speculated. If I click on this recipe, this is 267, right? This is not speculated, you can see. What if we would like to speculate this one? I'm going to just inspect it, go ahead and find that the link that starts with recipes is the one. So we can target it, right? So go ahead and I paste what I get, and I can get recipes. OK. Recipes, you can see here. If I did that and go back to application, you'll find that we have now all the recipes as well waited to be speculated. You remember it was 200 something to load? If now we just hover over it and it is ready, we click, it's 63. That's a big thing. That's really big thing. Applause. Not for me, right? Yeah. OK, let's go back to the presentation. The cool thing about using speculation rules that it doesn't have any kind of learning curve. You can just do what I did right now, get the script, try it today in your application, and just go brag with it in front of your manager and get a raise. Don't forget me. So that's something. Try it and gain it. And that makes a lot of companies just apply it real quick. You will see real implementation right now. And if you look here, you can check whether it is supported or not yet in the current browser. This means that you can make it as a progressive enhancement. And instead of doing it, shipping it everywhere, ship it only to the browsers that can benefit from it. So it might come to your mind, OK, can I just pre-render everything? Why not? Because people think about this when we think about lazy loading images. Lazy load everything, and this hurts LCP. And people just go back and learn it. This is exactly the same thing, just hashtag YOLO. Let's do it. Everything pre-render. Simple answer is no. No, you can't do that, and you shouldn't do that. You can do that for some stuff, because Chrome itself prevents you from doing that. First of all, if the user is enabling something called save data, this means that Chrome is ignoring any speculation rules. If you are opening any page in the background, it will be ignored as well. We're not speculating that. If you command click on something or control click, this means it's background. So we're not speculating for that. If the user enables energy saving, you are not speculating. If preload pages is setting to be off by maybe ad blocker or something, that as well wouldn't be speculated. Memory constraints. If you are loading a lot of things and maybe the memory of your Chrome is full, it's going to be ignored as well. We can do that, so ignore it. And finally, iframes are not being speculated. These are the limitations that Chrome comes out of the box with it. However, there is some stuff that you can do, but you should not do. Like anything, think about anything that you are preventing the search engines to think about it. It's the same thing. You should not speculate as well. Imagine that you are speculating sign out. So every time the user is in a page, OK, next one, please log in again. Please log in again. Doesn't work. Another one, sign in that requires like SMS or something. You're spamming the user. There's a lot of things. Don't do that. You can, but you don't. You shouldn't do it because you can, all right? It doesn't work like that. Another thing, language change. You know, one page is in English, another page in Chinese. Doesn't work. Another thing, if the user is getting some reputation or something through clicking on some links, you're giving something. You can't give him some reward for something he didn't do, right? Add to cart. Don't add something for the user. Another thing, if the URL is initiating like a server-side tracking or something, don't mess with your tracking. That's something as well that you need to prevent. So don't target anything of that. If you, by mistake, targeted something like that, you can find out through headers. You find this seek purpose, and you find pre-render or pre-fetch, and based on that, you can understand, OK, this is pre-rendered, shouldn't be, so you can remove from your target. There's ways to do that. Here is some real-world implementations that adapted that, and it was huge for them. WordPress, I think, is the most used CMS in the world, I guess, is adapting that through a plugin, so people can get there and say, all right, the eagerness decided with like radio button. This is important, and people are doing it. Akamai, SpeedKit, UXFi. This is interesting because UXFi is doing some analytics on the fly and change the behavior of the user. So you can use something like UXFi, and at the same time, gather this information, and they change the speculation rules to be personalized per user. This is a very big thing. If you are having like a funnel or something, you can change how the user behaves based on the information that you're gathering. Cloudflare, Astro, and so on. You can try it yourself, as you have seen today. Just try it in the console. If it works, you can implement that as well in your code. As a bonus step, there is something that was introduced recently. It's called dictionary compression. And this reduces the bandwidth, like a lot. You will see that. This is a standalone compression. What's happening is that you're finding out what's can be compressed, and you are doing it. But with dictionary, you're doing the same thing, but for different things, you're using one as a dictionary for the other one. Okay? So this means that if you have two versions, the first version has this huge code, second version has this huge code, plus only two changes, these blue lines. So instead of shipping the second version completely, you can just say, all right, get the second version with the first version as a dictionary. This means that you are shipping only like 1/10 of it or something. This is a very big thing. And there is some, discussion you can do that. And this is not something that as a front-end engineer you do. This is something to enable on the server, and you can benefit from it. Here's some results from it. Real quick, you can find that, for example, the YouTube desktop player has been down with like 85%. This comparison is between GZIP 9 and Protly 11, Protly 11 with dictionary. That's a huge. Why not to benefit from that? Why I'm saying that? Because speculation rules works really great alongside with dictionary. This means that if you are speculating like 10, and it's a big one, with dictionary you can speculate like 50, and still works fine. And you can ship faster application, hopefully. So what's now? It's your turn. First of all, you need to try the speculation API rules in your website, even with console logging and doing stuff. Play around with it. Try the compression with a dictionary, and try to share with me. Please reach out to me, tell me about the results, so I can even use it in my next presentation. Keep optimizing for the first load, because not everyone is looking for the navigation performance. People are usually looking for the first load, and even if they navigate with speculation enabled and it's good, and they reloaded for some reason, or maybe they landed on this page, they still needs the first load to be very good. And an extra tip, there's something called View Transition API that you can use alongside with speculation, so you get a seamless navigation. It's really, really good, very smooth. That was it. There's quite a lot of recommendation I can share with you to read more about it. The last one is from Pat Minana, is the guy who invented the dictionary thing in Google. So it's really must see video. And these resources is related to speculation and how to make an instant navigation as well. These are always the links that I recommend, MDN, web.dev, for everything performance and web. Please check them out. And this URL is for my website if you would like to connect and find all the social media. Thank you very much for listening up. That was it. Thanks.